Okay, guys, so now we're going to start with differentiation. Okay, so let's go to the whiteboard. Go to the whiteboard. We're going to start discussing the topic of differentiation. And we'll start with notation. Okay, let me just write here. Let me write here differentiation. 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 So first we'll start with we'll start with notation. Let's look at the notation that we use for differentiation. Okay, what notation do we use for differentiation? What notation do we use? Okay. Well, if we have a function, okay, if we have a function f of x, all right, so let's say for a function, let me say for a function, say for a function f of x, okay, wait, sorry. Okay, so I was saying, for a function f of x, this is how we denote the derivative of such a function. So for function f of x, we have the following notation for the derivative. We've got f prime x. Okay, so f prime x, it denotes the derivative of the function f. Okay, so we have a function f of x, and its derivative is denoted with an f prime x. Or you can denote it with a d f of x with respect to x. Okay, so we can say that for a function f of x, we have, for a function f of x, we have this notation. We've got f prime x or dfx dx. Both of these denote the derivative of f of x. So if we function f of x, we've got f prime x or dfx dx. Okay. And also another thing we have is, okay, we say if y is equal to f of x, if y is equal to f of x, okay, so also, as I was saying, if y is equal to f of x, if y is equal to f of x, then we have the following notation. Okay, we've got the following notation that we can use. Okay, we can say y prime, or we can say dy dx. So this notation, or this notation is notation that we use to denote derivatives. Okay, so f prime x is, if your function is f of x, f prime x, it denotes the derivative of the function f of x. And also the dfx dx denotes the derivative of f of x, you know. And if y is equal to f of x, then you can use y prime to denote the derivative of f of x, or you can use dy dx to denote the derivative of f of x. So that's the notation that we use. There's other notation for derivatives, but we use this notation here. So the things to focus on is this one, this notation here, and this here, and this here, and this here. This is the notation that we use for derivatives. This is the notation we use. Okay, so now let's go to derivatives. Let's look at derivatives from first principles. Let's look at derivatives from first principles. What we're going to do now is we are going to define what differentiation is. So now we're looking at the definition of derivatives. Okay, what is the definition of a derivative? So let's draw our Cartesian plane. This is our Cartesian plane here. We've got the y-axis. We've got the x-axis here. It's a Cartesian plane. Okay. Suppose that we have a curve here, curve that looks like this, or something like this. And this curve is just a general curve, by the way. It's not like a specific curve. This is just general. It's an example. And we're going to look at the definition of a derivative. Okay. So we have this curve. We've got the y-axis here. This is the y-axis. Okay. And the horizontal axis, that's the x-axis. Suppose that the equation of this curve is y is equal to f of x, like this. Okay. And suppose that along here, let's say, let this be x over here. So the point here on the x-axis, suppose that's this x. And let's choose another point. Let's say this point here is the point x plus h. Okay. So on the x-axis, over here we have x, and over here we've got x plus h. All right. Now, obviously, x plus h minus x gives us the difference, or gives us the distance between x and f plus h, or it gives us the difference between these two numbers, but it's basically the difference. I mean, the distance. So x plus h minus x is the distance between x and x plus h, and that is h. X plus h minus x is equal to h. So the distance between x plus h and x is just h. Okay. So, and that distance is the same as this one here. So this over here is just h. The length of this line here, which is parallel to the x-axis. Let me draw it again. I'm going to draw that line again. This line is basically the line parallel to the x-axis, and it's a straight line. And the distance or the length of this line is the distance between x and x plus h. Okay, so that's what it is. Now, again, the length of this line here, the vertical one, this one here, is the distance between f of x plus h and f of x. And f of x, you can indicate it along the y-axis, because that's where it is. Okay, there it is, there's f of x. And also f of x plus h, you can indicate it there along the y-axis. Okay, and that's where it is. It's f of x plus h. So the distance between over here, this distance here is the same as this distance here. Okay. Let me just use different colors for these distances. I'm going to use different colors. So let's just use purple for this one. So this distance here, this vertical distance from between f of x plus h and f of x is obviously given by f of x plus h minus f of x, and it's the same as this distance here. It's the same as this one here. So I keep rubbing the wrong thing. Okay, I'm trying to get rid of this thing here. I keep getting rid of the wrong thing. Let me just go back to this. Okay, so as I was saying, that distance in purple there is the same as this one here, same distance. And also, let me do this. Let me also say that this distance here, okay, let me say that this distance here, the one in green, is h, and it's the same as this distance here, h. Okay, so this distance are the same, and the one in green is h, that's h, and the one in purple is basically given by f of x plus h minus f of x. Okay, so that's what gives you these distances. Now, this is basically the gradient. The gradient, specifically the gradient is given by f of x plus h, which is this distance here, the vertical distance, which is f of x plus h minus f of x. That's the vertical distance. If you put the vertical distance over the horizontal distance h, then you've got the gradient of f of x at x. This is the average gradient. So this quantity, f of x plus h minus f of x divided by h, is the average gradient of the function f of x at x. So now, how do we find the derivative of the function using this information? Well, what we do is we simply get the limit. We simply get the limit of x plus h minus f of x over h as h approaches 0. So just imagine that this distance here, h, is getting smaller and smaller and smaller. So everything is shrinking. If h is getting smaller, that basically means that f of x plus h minus f of x will also get smaller. It'll also get smaller and smaller. And it's getting smaller and smaller, approaching 0, but it never really gets to 0. Okay? So the derivative of the function f of x is defined as the limit of this gradient as h approaches 0. So that's what the derivative is. So that's how we define it. We say then f prime x, which denotes the derivative. So this f prime x denotes the derivative of function f with respect to x. This f prime x then is given by the limit of this gradient, which is f of x plus h minus f of x over h, as h approaches 0. Okay, that is how you define the derivative. That's the definition of a derivative of a function. So now, let's go to examples. We're going to go to examples of how we can use this definition to calculate the derivative of functions, because we can use this definition to calculate the derivative of functions. And when we calculate the derivative of functions using this definition, we call that differentiating from first principles. That's what we call it. We call it differentiation from first principles, or differentiating using first principles. Okay, differentiating from first principles, or differentiating using first principles. That's what we call it. Okay, let's go to the next page. Okay, let's look at this example here. In this example, we are asked to differentiate the following. We say differentiate the following function Okay, so in this example, we have to differentiate the following function from first principles. Okay, differentiate the following function from first principles. Again, differentiate the following function from first principles. And the function that they give us is the following functions. F of x is equal to 4x squared plus x plus 2. Okay, guys, as I was saying, so we are given this example. Okay, in this example, we are asked to differentiate the following function from first principles. We've got f of x is equal to 4x squared plus x plus 2. So how do we then differentiate this function using first principles, meaning using this definition here? How do we do this? Okay, so this is a simple thing. All we have to do is we have to find out what f of x plus h is. So we start there. What is f of x plus h? Because we're going to need it. We are going to need this f of x plus h. What is it? What is f of x plus h? We have to calculate this because we are going to need this. We have to calculate f of x plus h because we're going to need it. So what is f of x plus h? Let's look here. We need f of x plus h for this formula because we need to use this formula, this definition. We need to use it in order to calculate this derivative. So what is f of x plus h? Let's go calculate it for this function. It's simple. All we have to do is we have to substitute this x plus h into the given function. So let's go ahead and do that. We've got 4 multiplied by x plus h squared. So we just replace x with x plus h in our function that is given. In place of x, we put x plus h plus 2, like that. So we got 4 multiplied by x plus h to the power 2 plus x plus h plus 2. So as you can see, we basically just replace x plus h, we replace x with x plus h in our given function to get our f of x plus h. So let's go ahead and expand it, because we're going to need to expand it. So x plus h squared is basically just x squared plus 2xh plus h squared, okay, plus our x plus h that we have. So that stays the same, okay. And we also have our plus 2. This is h over here, okay. And let's then multiply. We're going to multiply the 4. We'll multiply 4 into the bracket. Just distribute the 4 into the bracket. And that's going to give us the following. It gives us 4x squared plus 4 times 2xh is 8xh plus 4 times h squared is 4h squared plus x plus h plus 2. So that's what we get. So that's what we get. Now, can we expand it further? Are there any like terms? I don't see any like terms, and so for now we just leave it like this. We have our x plus h, our f of x plus h. So let's go to the formula and see what we need this for. We've got f of x plus h at the top of this fraction here, this gradient. We have f of x plus h minus f of x. So now we just calculated f of x plus h. Now we need to need to subtract f of x from f of x plus h, so we can get the numerator of this fraction. So let's go ahead and subtract this 2. Okay, we say therefore f of x plus h minus f of x is equal to the following. It's equal to what we have at the top there, which is 4x squared plus 8xh plus 4h squared plus x plus h plus 2. Now we subtract. We're gonna subtract with minus. We subtract. We got 4x squared plus 8xh. 4x squared plus 8xh plus 4h squared plus x plus h plus 2 minus f of x. And f of x is just simply that 4x squared minus x. 4x squared plus x plus 2. So minus that is simply, just to save time, I'm going to just go straight and just minus. So minus f of x is basically just minus 4x squared minus x minus 2, like this. So you just subtract it. And then let's look, do we have any like terms now? Are there any like terms now in this, as we subtract these 2? Let's look here. We've got 4x squared and we've got 4x squared. We've got minus 4x squared. So the 4x squared, it cancels out with this minus 4x squared, gives us 0. Is there any other like terms? We've got x plus x here and a minus x. So these are like terms, they cancel out. And we also have 2 here, plus 2, minus 2. This 2 cancel out. So it looks like what we have left is just 8xh. So we've got 8xh, which is this one here. We also have the plus 4h squared. So we also have that plus 4h squared, which is this one here. And also the plus h. So all these terms that we have left all contain h. Okay. And that's what we have. Okay, so that's what the difference of these two gives us. It gives us this. So that's the top, or that's the numerator of our fraction then in our limit. Now the bottom is just age. So let's just go and conclude. Let's see where this leads. So we say therefore the f prime x then, the f prime x, or the derivative of the function f of x with respect to x, is then given by the limit. It's given by the limit when age goes to 0 of what? Okay, the limit when age goes to 0 of what? Well, of what we have here, calculated, that is 8xh. We've got 8xh, that is f of x, f of x plus h minus f of x, which is the top of the fraction. And it's given by 8xh. So we write this here, we've got 8xh, and we've got plus 4h squared, okay, plus 4h squared. And let's go back and see what's going on here. We've got plus h, okay, 4h squared plus h, and we divide this by h, like this, okay? So that's what our derivative is given by. So f prime x is given by this limit. So before we calculate the limit, we want to cancel out the h. Because h is a common factor, and we cannot just substitute in, because what we want to do is we want to use continuity to calculate this. We want to use the concept of continuity, and continuity means that we are going to substitute 0 into the function in place of h. But at this point we can't, because we cannot divide by h. So, but because the numerator has age in it, each term of the numerator has got age in it, we can then factor out the age in the numerator and cancel it out with the age in the denominator. So basically what that means, it means this: our next step is the following. Okay, age approaches 0. At the top, we factor out the h, and inside the bracket here, we've got 8x, and we've got plus 4h, and we've got plus 1, right? Because we factor out the h. So we've got 8x plus 4h plus 1. That's what we have at the top, okay? And we divide, of course, by h. So what we did now is just factor out the h at the top, or in the numerator. And this is what we get. And we can see clearly that now we cancel out the h at the top here and the h at the bottom here. And that gives us the following. It gives us the limit when h goes to 0 of the following, of 8x plus 4h plus 1. So it gives us this. So now we can then use our continuity, because now there's no, when we substitute 0 into the function here, there is no problems, there's no errors, there's no undefined quantities. So now we can just quickly just substitute 0 into function in place of h, and that is our limit, which is our derivative. So we've got 8x plus 4h. In place of h, we put 0, and of course we plus 1. And 4 times 0 is of course 0. And therefore our derivative of our function is then equal to 8x plus 1. 8x plus 1. So that's what gives you the derivative. So this is called differentiating from first principles. We differentiate the function f of x is equal to 4x squared plus x plus 2 from first principles. We have differentiated this function from first principles. We have differentiated this function from first principles. And now we're going to move on to, let's move on to the rules of differentiation. Okay, now that we know what the definition of differentiation is, and we know how to use the definition to calculate a derivative of a function, we can now move on and discuss the rules of differentiation. What are the rules that we use when calculating derivatives? Okay, you can also call them laws if you want. You can call them laws or you can call them rules. Okay, so I'm going to say the rules of differentiation. The rules of differentiation. The rules of differentiation. Okay, the rules of differentiation. Let's start with rule number one. Let's call this rule number one. Okay, I'm going to start by the following. So let's differentiate x to the power n with respect to x. What is the derivative of x to the power n with respect to x? What is the derivative of x to the power n with respect to x? What is the derivative of x to the power n with respect to x? Well, this is given by n multiplied by x to the power of n minus 1. You must always remember this. This is the rule. One of the important rules of differentiation. If you differentiate in x to the power n is of course some number, okay? Any number. This is equal to n multiplied by x to the power of n minus 1. Okay, let's take that to be rule number one. And then number two, let's discuss now the derivative of a sum. What if you differentiate the sum? A sum of two functions, a sum of f of x or the difference. Okay, or the difference. Okay, so what is the derivative of fx plus minus g of x? Well, it's simply equal to the derivative of f of x with respect to x plus minus the derivative of g of x with respect to x. It's as simple as that. Okay, give me a second. Okay, guys, so as I was saying, okay, let me see. Okay, so that's the second rule. Now the third rule is as follows. We're differentiating. What is the derivative? What's the derivative of c? And c is a constant in this case. C is just any constant. What's the derivative of a constant c multiplied by the function f of x? That's equal to the following. So you can take out the constant. You can factor out the constant, take it out, and multiply it by the derivative of the function f of x with respect to x. Okay, so if you differentiate the constant, multiply by function f of x, that is equal to the constant times the derivative of f. So you can factor out the constant. Okay, let's go to rule number 4. Rule number 4 is what happens when you're differentiating a constant, just a constant, c. So you're differentiating just c. If you're differentiating a constant c, that is just going to give you 0. So the derivative of any constant is equal to 0. Okay, and next one, rule number 5. Number 5, we are differentiating the product of two functions. What's the derivative of the product of two functions? Let's say the derivative of f of x multiplied by the derivative of g of x. What is the derivative of f of x times the derivative of g of x? In this case, we do the following. We go f of x multiplied by the derivative of g of x, okay, plus g of x multiplied by the derivative of f of x. Okay, that's how you calculate that. So the derivative of a product of two functions, f of x and g of x, is given by the following. Okay, just give me a second there. Okay, sorry guys, I'm back. So that's the product rule. If you differentiate the product of two functions like this, the derivative of f of x times g of x, it's equal to is f of x times the derivative of g of x plus g of x times the derivative of f of x. So that's how you calculate that. And then lastly, we're gonna look at the last rule we look at, which is the following rule. This is the derivative with respect to x of the following. This is the derivative of f of x divided by g of x. The derivative of f of x divided by g of x. Derivative of f of x divided by g of x. And so this is given by the following. Now for this one, you go g of x multiplied by the derivative of f of x with respect to x minus f of x multiplied by the derivative of g of x with respect to x. Divide this thing here by g of x. Okay, divide this by g of x to the power of 2. So this is the quotient rule of derivatives or of differentiation, and that's how you do that. Okay. Now I'm gonna give you guys examples to work on. Give you three or four examples to work on. I'll give you some time to solve this, 5 minutes or so. To solve these examples, so you're gonna calculate y prime. Okay, calculate y prime for some functions. Okay, you're gonna use these rules to calculate these derivatives. You're gonna use the rules we just went through. Okay, to calculate this, you're gonna use the rules. Okay, okay. Let's see we got 1, 2, 3, 4, 5, 6 rules. Now I'm gonna write down the examples, and I will give you guys some time to work on these. Okay, 5 to 6 minutes or so. So the instruction in this example is saying calculate. The instruction says calculate y prime. Calculate y prime for the following. So calculate y prime for the following. That's the instruction. Calculate y prime for the following functions. Okay. Number one, y is equal to x cubed plus 2x squared minus 5x plus 1. Okay. Number two is x squared. Number two is x squared plus x plus 2. Okay, this doesn't look like x now, it looks like something else. Let me just fix this, please. Go back and write x, this x. So we got x squared plus x plus 2 multiplied by 5x squared plus 4x, okay, minus 1. And number 3 is the following. It's y is equal to, no, this is y, sorry. Number 1 is y is equal to this. 2 is y is equal to this. Number 3 is y is equal to the following. It's 6x plus 3 divided by 7x squared, okay, plus 2x plus 3, okay. So now I'm going to give you guys a few minutes to work on these. You have to calculate these using the rules we've just discussed. Go ahead, please. Okay, guys, we're going to continue now. We're going to go through the solutions of these examples. Okay, let's go to the next page. Let's start with the first one. Number 1. So if your y is equal to x cubed, so your y is equal to x cubed plus 2x squared minus 5x plus 1. X cubed plus 2x squared minus 5x plus 1. So we have to find y prime. Okay, so therefore y prime is equal to the derivative of y with respect to x, and which is basically the derivative of x cubed. Okay, x cubed plus 2x squared minus 5x plus 1. Okay, so now we differentiate this function with respect to x. Now we're going to use the rules that we covered earlier. Okay. What do the rules say? The derivative of a sum or a difference is the sum or difference of the derivatives. Simple as that. So we apply this rule to this and see what we get. Okay. So let's go ahead and do it. So this is equal to the derivative of x cubed with respect to x plus the derivative of 2x squared with respect to x. Okay, plus or minus in this case the derivative of 5x with respect to x plus the derivative of 1 with respect to x. And if you want, you can put brackets around this. You want brackets around each of them as you're differentiating. So now we're going to differentiate each of these terms here, each of these things. We're going to differentiate each of them and see then what we get when we do so. Let's see what we get when we do so. Okay. Let's see what we get when we do so. Okay. Let's start with the derivative of x cubed. What is the derivative of x cubed? What is that? If we're differentiating x cubed using the first rule, this is equal to 3 multiplied by x to the power of 3 minus 1. That's what the first rule we covered says. And now the 3 minus 1, we can just put 2. Okay, let's just put 2 because 3 minus 1 is 2. What about the second one, second term, the derivative of 2x cubed? The derivative of 2x squared. The derivative of 2x squared, now, first of all, we have a 2 multiplied by x squared. So we can take out the 2 as a constant. So you can just take out the 2 and then differentiate x squared. When you differentiate x squared, that'll give you a 2x to the power of 2 minus 1, which is simply just 1. Okay, so we can just leave it like this, 2x. And then the third term, you have 5. You can take out the 5 as a constant, factor it out because it is a constant. So you take it out because it's a constant, and you are left with the derivative of x with respect to x. Applying the rule, that's basically just 1 times x to the power of 1 minus 1. It's 1 times x to the power of 1 minus 1. 1 minus 1 is just 0. Okay, so you got x to the 0. Now x to the 0 is 1, so you just have 1 basically. So you just leave this as 1. Or you can look at it as dx over dx. They cancel out to give you just 1. So Either way, you get 1. And you have, of course, the 5 that you factored outside. So you got minus 5 times 1, which is basically just minus 5. Now, the last term is the derivative of 1 with respect to x. And because it's a constant, and we said that if you differentiate a constant, you're going to get 0. So this is basically just going to give you 0. Okay? So now let's see. Let's simplify. So we've got 3x squared in the first term. And we've got plus 2 times 2, which is 4. So that's 4x minus 5. Okay, so we've got that. So that is the derivative then of this function y. This is y prime. It's 3x squared plus 4x minus 5. Okay, now let's head on to the second one, number 2. In number 2, they give us a product. Okay, so they say we must find y prime. In this case, y prime is the derivative with respect to x of the product. And the product that they give us is x squared plus x plus 2. And we multiply this by 5x squared plus 4x minus 1, like this. So you multiply these two, x squared plus x plus 2 times 5x squared plus 4x minus 1, multiply this 2. You differentiate this product. And applying the product rule, you have the following. So you've got x squared plus x plus 2, and you're going to multiply this by the derivative with respect to x of 5x squared plus 4x minus 1. And then you're going to subtract, not subtract, so you're going to add plus 5x squared plus 4x minus 1 multiplied by the derivative with respect to x of x squared plus x plus 2. Okay, so let's first differentiate then the 5x squared plus 4x minus 1. If you're differentiating this, obviously you're going to differentiate it term by term, because that's what the rules say. So differentiating 5x squared, what does that give you? That'll give you a 10x. So first we're going to write this x squared. We're going to write the x squared plus 2, sorry, plus x. Okay, it's x squared plus x plus 2. So we write that first. And we're going to multiply it by 10x, multiply by 10x. Okay, so we multiply it by 10x, and we're going to add the next derivative, which is the derivative of 4x. The derivative of 4x is simply just 4. Okay, so I add 4 minus the derivative of 1, which is a 0. So that's what we have. And when I say plus, go to the next one, and we're going to write the 5x squared plus 4x minus 1. And we're going to multiply this by the derivative of x squared plus x plus 2. Again, we're going to differentiate this term by term. The derivative of x squared is just 2x. We're going to write 2x. The derivative of x is just 1. So we're going to say plus 1. The derivative of 2 is just 0. So plus 0. Now we have this. Now, once you have this, this is now the derivative of y, in this case. This is y prime. And you do not have to expand these things. You found the derivative, you just leave it like this. This is the answer. You don't have to multiply the brackets and stuff like that. Once you find the derivative, you can leave your answer like this. So this is the final answer. The final answer is this. This is the final answer here. Okay. All right. Now we're going to go to the next one and calculate the derivative of this quotient. Let's go to the quotient, which is number 3. We're going to calculate the derivative of the quotient that they give us. Okay, so y prime in this case is the derivative with respect to x of the following. It is of 6x plus 3 divided by 7x squared plus 2x x plus 3, like that. So it's the derivative of a quotient, okay? Two functions divided by each other. In this case, applying that quotient rule that we discussed earlier, this will be 7x squared plus, so you start with a function at the bottom in this case. The order is important in this case. So you go 7x squared plus 2x plus 3, okay, multiplied by the derivative of 6x plus 3 with respect to x, okay? And in this case, you say minus 6x plus 3, all right, multiplied this time by the derivative of 7x squared plus 2x plus 3 divided by, or with respect to x, the derivative of 7x squared plus 2x plus 3 with respect to x. And then you you divide all of this by the 7x squared plus 2x plus 3 to the power of 2. Now you're going to go and differentiate these functions. Okay, you're going to differentiate 6x plus 3. So you're going to start there. So let's write this 7x squared before we do that. 7x squared plus 2x plus 3. Okay, and what is the derivative of 6x plus 3? If you differentiate 6x, you get 6, right? And if you differentiate 3, you get 0. So you're going to get 6 here. You're just going to put 6 here. You're going to go minus. Then you're going to go minus. You're going to get 6x plus 3. And then you go differentiate 7x squared plus 2x plus 3. If you differentiate 7x squared, what's that going to give you? That is going to give you 14x. Okay, 14x. And if you differentiate 2x, you're going to get plus 2. If you differentiate 3, you're going to get 0. So you're just left with 14x plus 2. So you've differentiated, and that now you're going to have to divide by the function at the bottom, which is 7x squared plus 2x plus 3 to the power of 2. So that's what you have. That's what you have. So this is your final answer. Again, you don't have to go and simplify this thing and multiply the brackets and all that and expand it. You don't have to. You leave it like this. This is your final answer. So after you differentiate, you get the final answer, and that is your final answer. You don't need to do anything else there. That's where you leave it. That is where you leave it. And guys, this lecture here, this is our last lecture for this semester. Okay, so this lecture here is the last lecture for this class for this term. All right, we're going to continue with differentiation in the next semester, and then move on to integration and so forth, and the work that comes after that, which is statistics and all those things. So, yeah. So anyway, let's move on to the next thing, which is the derivative of certain functions. Okay, so now we're going to look at derivatives of certain functions. Derivatives of certain functions. Okay, derivatives of certain functions. Now the derivative of certain functions, we're just going to look at specific functions. Okay, and these derivatives you have to remember. Okay, I'm not going to give you guys, I will not give you. I won't give you these derivatives in the formula sheet. Okay, there are derivatives that I'm going to give you guys in the formula sheet so that you remember, but there are derivatives that I will not give you in the formula sheet. So you must just be aware of that. There are things I'm going to give you in the formula sheet, and there are things that I'm not going to give you in the formula sheet. Now for these ones I'm going to write now, I'm not going to give you in the formula sheet. It's something that you have to remember. Okay, let me write them down quickly. So now these are the derivatives. Well, these are the derivatives. These are the derivatives of certain functions that you just must remember. Derivatives of certain functions, okay, that you just have to remember. You have to learn off by heart. These are derivatives of certain functions that you must remember off by heart. Derivative of certain functions that you must remember off by heart. So number one, what is the derivative of e to the power x? The derivative of ex, what is that? The derivative of ex is equal to ex. I think this is the only function in mathematics where that behaves like this, where its derivative is the same as the function. Okay, the derivative of this function is the same as the function. The derivative of ex is equal to ex. Okay, and then number two, you've got the derivative of ln x. The derivative of ln x. What is the derivative of ln x with respect to x? The derivative of ln x with respect to x is 1 over x. Something that you must just remember. The derivative of ln x with respect to x is 1 over x. And then number three, what is the derivative of a to the x? Okay, the derivative with respect to x of a to the x is simply just equal to a to the x multiplied by ln a. Something you must remember. Okay, and lastly, what is the derivative of log ax? So the base of this log is a. All right, what's the derivative of log ax? Okay, so it's a log, basically it's a log with a base a. The derivative of this is 1 over, it's 1 over x times by ln a. 1 over x multiplied by ln a. That's the derivative of this one, of this general logarithmic function, log ax. It is equal to 1 over x ln a. So these derivatives of these functions, you have to remember these. They will not be given to you in any formula sheet. Okay. Okay. So now I'm going to give you examples. Okay. Give you examples to work on. I'm going to give you examples to work on. Okay. Give you examples to work on. Give you some time to work on them, maybe like 2-3 minutes or so, to work on these examples. Okay, right. Let's go to the examples on the next page. Say examples. Examples. Number one. Before we say that, let's first write down the instructions of this. The instructions are calculate. The instructions are calculate dy dx. Calculate dy dx for the following. So calculate dy dx for the following. So number one, y is equal to 5 to the power of x. Okay. And number two is y is equal to log 2x. Okay, so 5 to the x, log 2x. So now, let me give you guys a few minutes to calculate this. You just have to work it out using what we've just discussed. So meaning you're going to use this. You're going to use the derivatives of certain functions. Okay, if you look at the first derivative, first function is 5 to the x. So let's see what we're going to use for this one. For this one, we're going to use number 3. The derivative of a to the x with respect to x. What is that? And the next one, number 2, is log 2x, general logarithmic function. So we're going to use number 4. So it's just simple like that. Simple example where you apply this derivatives of certain functions. Okay. Again, as I said, these things you have to remember off by heart. You will not get them in the formula sheet. Okay. These things you must remember them off by heart. You will not get them in the formula sheet. Yeah. Okay. Now, excuse me. Okay. All right. Okay. I think let's just quickly go and discuss them. I'm sure you've already finished doing them. For the very quick, you just use the formula given here. very quick. So let's just go and discuss them. Number one. Okay, let's discuss number one. Okay, let's discuss number one. Let's see. Number one. Now with number one, uh, okay, so number one, dy dx is equal to the derivative of 5x with respect to x. Okay, so using uh, 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 using number three over here, we say that this is basically equal to 5 to the power x multiplied by a ln of 5. Simple as that. 5 to the x times ln of 5. That is the derivative of 5 to the x. It's 5 to the x times ln 5. And then the next one, they want us to differentiate the following. So we got dy dx, which is equal to the derivative of log with a base 2 of x with respect to x. So this is equal to the following. So applying now, we're going to apply number 4 here. Okay, log ax is equal to 1 over x ln a. Okay, so let's see what we have here. In this case, we got log 2x. So this is going to basically just equal to 1 over x, okay, ln 2. Because our a in this case is 2, so it's 1 over x ln 2. Simple as that. So that's how you calculate these derivatives. It's very simple, straightforward. But you have to remember these formulas. These ones you have to remember off by heart. You must remember them. And then let's move on to the next thing. Next thing is the derivatives of trigonometric functions. Now the derivative of trigonometric functions, again, now for these ones, I am going to give you these ones in the formula sheet to remind you. I think these ones, you have to have them in the formula sheet, just to remind you of what these things are. So these are the derivatives of trigonometric functions. The derivatives of trigonometric functions. You have to have these ones. Again, derivatives of trigonometric functions. These ones you're going to get in the formula sheet. So these ones you will get them in the formula sheet. Now, let's start this. So this is let's start with the derivative of sine x equals to cos x. Okay. Number two. So we start with the derivatives sine x and the derivative of cos x with respect to x. This is equal to minus sine x. So the derivative of sine x is cos x. Derivative of cos x is equal to minus sine x. The derivative of tan x with respect to x is equal to sec squared x. Okay. And number four, now let's go to the reciprocal functions. The derivative of cosec x with respect to x is equal to minus cosec x multiplied by cot x, okay? And then number five, the derivative of sec x with respect to x is equal to positive sec x multiplied by tan x. And number six, the derivative of cot x with respect to x is equal to minus cosec squared x. So this is the derivative of trigonometric functions. You can obviously you have to apply this. You are going to apply these derivatives. You're going to use them. You don't have to learn them off by heart, but if you want to learn them off by heart, you can. It makes things easier if you do. But I would definitely provide this to you in the formula sheet. Okay, I'll provide this to you in the formula sheet. Definitely. But that's what they are. We're going to apply them. And before I give you guys examples of the last examples for this session. I'm going to first discuss with you the power rule. Let's discuss the power rule. Let's discuss the power rule first before I give you examples, which will be the last examples for this session. So this is the power rule. Okay, power rule. What is the power rule? Simple. It states the following. If I'm differentiating a function, okay, I'm differentiating a function f of x, and this function is put to the power n is some number. So the derivative of f of x to the power n is simply equal to n multiplied by the function f of x to the power of n minus 1 multiplied by the derivative of this function f of x with respect to x. So the derivative of f of x to the power n is equal to n multiplied by f of x to the power of n minus 1 multiplied by the derivative of f of x with respect to x. That's what the power rule says. So any function, if you're differentiating any function put to the power of n, whatever n is, then this is what you do to evaluate the derivative of that in that situation. So now let me give you the examples, okay? Now in the examples, what you have to do is simply differentiate the following functions. Now you're going to apply the power rule here, okay? And you're also going to need your trigonometric functions, also the derivatives of trigonometric functions. So the first number, or the first one here, is the derivative of the following. It's the derivative of cos x to the power of 3. What is the derivative of cos x to the power of 3? And then number 2, what is the derivative, of course, with respect to x, of the following, of x multiplied by ln x to the power of 2? Okay. Number 3, what is the derivative with respect to x of sec squared x? Okay, so what are the derivatives of these functions here? I'm going to give you guys time to work on this. But of course, again, you can just pause the video. Okay, you can pause the video and then work on these before you look at the solutions, just to practice. I don't have to pause because I'm recording, so I don't have to pause. But what we can do is that you can just pause the video yourself, work on these examples before you look at the solutions, and then look at the solutions afterwards. Okay. Let me just look here. Sorry. All right. Okay. Is it fine? Let me just see. I don't know. I think everything is fine, if I'm not mistaken. Okay, let me just go back here. Looks okay. Okay, looks okay. Things look okay. Let me just now go to the solution. So let me go through the solutions anyway. As I said, pause the video before you look at the solution. Work on these, and then look at the solutions afterwards. So now we're differentiating with respect to x, and we are differentiating cos x, and this is to the power 3. Now, of course, for trigonometric functions, this 3 you can put it here. Okay, trig functions you can put when you put trig functions to the power of some number, you can put the number here, you can put it here, or you can put it here. Okay, you can put it inside like this, or you can put it outside like this. Either way, it means the same thing. But we are going to apply the product rule, which states this. No, not the product rule, the power rule. Power rule states that in this case, you put the 3 in front, and then you multiply by cos x to the power of 3 minus 1, which is just, 2. So you can just put 2 here. And then you multiply this by the derivative of the function inside, which is the derivative of cos x in this case. And that's how you evaluate this derivative. So obviously, since it's a trig function, you can, if you want, to just write it like this, cos squared x. And you multiply this by the derivative of cos x, which is minus sine x. If you look at those the derivative the derivatives of trig functions, you'll see that the derivative of cos x is minus sine x. Let's go look at them. The derivative of cos x is minus sine x. So you just substitute that in there, and then your final answer, just to write it in a neat way, just to write it in a more neat way, you can write it as minus 3 sine x multiplied by cos squared x. And that is your solution. That is your answer for this one. Let's go to the second one. Not wasting time. Let's go to the second one, number 2. In number 2, we are differentiating sec squared x. No, we're differentiating x ln x to the power 2. So we're finding the derivative with respect to x of x ln x to the power of 2. Okay, that's what we're doing. So we've got x ln x to the power 2. Now, again, power rule. Okay, because we got a function to the power of some number. In this case, 2. So we're going to put 2 in front, and we're going to multiply the 2 by x ln x to the power of 2 minus 1. Now, 2 minus 1 is just 1. So we can just remove this and put 1, or we can just leave out the 1 because, it's the same thing. Just write it like this. Now we're going to multiply this, of course, by the derivative of the function inside. And the function inside, obviously, is your x ln x. Now, we've got x times ln x here. So it's a product of two functions. So it looks like we have to apply the product rule in there. So we basically have 2 multiplied by x multiplied by ln x multiplied by this derivative. So in this situation here, we are going to apply the product rule. And let's go and apply it then. X multiplied by the derivative of ln x with respect to x plus ln x multiplied by the derivative of x with respect to x. Okay, and let's go ahead and see. So now we've got 2x multiplied by ln x multiplied by all of this. Now ln x, the derivative of ln x is 1 over x. We know that because we discussed that, okay, when we were discussing the derivative of certain functions. We saw that the derivative of ln x is 1 over x. So we can apply that here. Okay, let's go back. Let's go back where we are. Let's go back to where we are. So the derivative of ln x is 1 over x. So now we've got x in the outside, and then in the inside, the derivative is 1 over x. And these two x's are going to cancel out. So these two, they cancel out like this, and we are just left with 1. So we can just put 1 here, because they cancel out anyway. Let's just put 1. And then over here, we've got plus, we've got ln x dx. We've got ln x times dx, which is just 1. So we basically have just ln x here. All right. So that's what it is. We've got 2x ln x times 1 plus ln x. Now, you can leave it like this. You can leave it like this. Or you can multiply it through. You can multiply it through and get 2x ln x plus 2x. So you just multiply the 2x ln x inside the bracket. You get 2x ln x in the first term. Second term, you get 2x multiplied by ln x. Now the ln x is to the power 2. So the 2x multiplied by ln x to the power 2. Because you multiply, ln x twice. It's ln x times ln x. So basically ln x to the power 2. And so that's your final answer. This is your answer here. That's the derivative of that function. So we can leave the answer like this, or you can leave it here, really here. You don't have to multiply it through, but it looks better when you multiply it through. It looks neater, but it is what it is. Okay, so now let's move on to the next one. Next one, which is the last one. In the last one, we are required to calculate the derivative of the following. We've got the derivative with respect to x of sec squared x. Now again, sec squared x is the same thing as sec x to the power 2. Okay, this is the same thing as the derivative with respect to x of sec x, sec x to the power 2, like that. Okay. Again, you're going to use the power rule. 2 multiplied by sec of x, okay, to the power of 2 minus 1. But then, again, 2 minus 1 is just 1. So it's just 1. Okay, it's just 1. And the 1, you can just leave it out. Okay, now you're going to multiply this by the derivative of the function inside, which is sec x, like that, with respect to x. Okay, now the derivative of sec x, first let's write down the 2 sec x. 2 sec x, okay, multiply by the derivative of sec x. The derivative of sec x, if you go look at the list for the trig derivatives, you find that the derivative of sec x is simply just equal to positive sec x multiplied by tan x. Okay, that's what it's equal to. So ultimately, your final answer will be 2 multiplied by sec squared x, because it's just you multiply them twice. It's sec x times sec x, that's sec squared x, multiplied by 10x, like that. So that's your final answer. Your final answer is this thing here. Let's go back. So your final answer is this here. 2 times sec squared x times 10x. That's your final answer. And this is where we stop. Okay, this is the where we stop. This is the last lecture for the term. Okay, so we stop here. Thank you for joining, guys. I'm gonna post this on the thing. I'm gonna post this. Okay. Thank you very much. Let me just go back to that thing. As I said, I'm gonna post this on Blackboard. Thank you for joining. Okay. Let me stop now. I'm gonna stop this.